Let us evaluate the integral of secant to the power of 3 of x. Whenever we are dealing with an integral of secant and our exponent is an odd number, we must first factor out secant squared of x. So this would be the integral of secant of x multiplied by the factored out secant squared of x, multiply it by dx. We can think of this part as the whole dx now. Next up would be to use integration by parts. The formula for that would be the integral of u multiplied by dv would be equal to u multiplied by v minus the integral of v multiplied by du. So in our case, u here would be secant of x and dv right here would be secant squared of x dx. Assigning values. The derivative of secant of x would be equal to secant of x multiplied by tangent of x dx. And focusing on dv now, dv right here would be equal to secant squared of x dx as given in here. And let us take the integral of it. So this would be now v. The integral of secant squared of x is actually equal to tangent of x. No need to put plus c. It is not necessary yet. Now that we have our values here, just plug it according to the formula. So this would be secant of x multiplied by v value, which is tangent of x, minus the integral of v, which is tan of x multiplied by du, which is this one, secant x multiplied by tan x dx. Actually, no need to put parentheses here. Let us now simplify this. Let me just erase this. Simplify this first. You can see here that we have two tangent of x. We can combine them. Combining these two, it would result in tangent squared of x, and copy the rest. Now, we cannot simply use u substitution against either of these because the derivative of tan of x would be secant squared of x. But what we have here is simply secant of x. And when we do u substitution in here, it cannot be also because the derivative of secant of x would be secant x multiplied by tangent of x, which cannot be simplified further. So what we're going to do here would be to use other trigonometric identity, focusing on tangent squared of x. Let me just copy this first. Based on that trigonometric identity of tangent squared of x, it is actually equal to secant squared of x minus 1. So by rewriting this one, and copy the rest, distribute now secant of x again among the parentheses values. So this would be secant cube of x minus secant of x of dx. And next step would be to split this integral into two parts. This would be the integral of secant cube of x dx. Since what we have here would be negative and our integral here would be negative, this would result in a positive integral of secant of x dx. If you can see here now, if you can notice, we have an integral of secant cube of x, which is actually our problem right here. You might think that we are stuck in a loop because we would have to do it again. But no, there's actually a simpler way. If you had analyzed it, this secant cube of x is actually equal to this value right here. We just modified it. And now we can actually equate this to each other. So this would be the integral of secant cube of x dx be equal to this value right here. Our objective here would be to eliminate secant cube of x because our problem is the same also. What we're going to do would be to move this one to the other side, or since this is a negative value, add both sides secant cube of x. This would be plus integral of secant cube of x dx. What we're going to do on this side, repeat on the other side. So for that, this would equal to 0. This would equal to twice the integral of secant cube of x dx. Since they are just the same, it will just add and copy the rest. And now, since what we only need here would be the integral of secant cube of x, we would want to get rid of these two value right here. Now what we're going to do would be to divide all sides by 2. So this would be cancelled. We just make some space here. Our result here would be the integral of secant cube of x dx. It reverted back to the original again. So for this, we can actually put this as 1/2 multiplied by secant x tangent of x. It is just the same. And also for this, just multiply it by 1/2. The integral of secant of x dx. What we have here is now fine, and the only thing left would be to solve the integral of secant of x dx. Solving this would require another video of mine. I will be uploading it later on. So for now, I will just be putting the answer of the secant of x because it is quite a long explanation on how it is. So I will just put it. So this would be 1/2 secant of x multiplied by tangent of x plus 1/2 multiplied by the integral of secant of x dx would be equal to the natural log of the absolute value of secant of x plus tangent of x plus c. So this is also equal to the integral of secant cube of x dx. And now this would be your final answer on the integral of this.